Hey, what's up, y'all? My name is Nicholas Chervin, and today I'm going to be talking to y'all about sample size because you know what? It takes more than 3 to have a party. All right, let's get into it. All right, so what is sample size? And that's kind of a twofold definition. So a sample are the data points chosen from a broader total population in order to more concisely form a representation of that population. And then the size is in reference to the total amount of data points. When you combine those terms, sample size equals the number of data points used to represent a population. So why is sample size even useful then? Sample sizes are useful in making inferences on large data sets. This ultimately allows researchers to extrapolate conclusions more concisely. But there are some limitations to sample size. For example, a small sample size may lead to a sample population that is not representative of all groups in the total population. This makes it difficult to determine if a particular finding is representative of the total population. But also, too big of a sample size, and now you're wasting time, money, and resources for data that may not greatly affect your results. Another limitation is population constraints. This means that participants' needed may be difficult to access, which makes it difficult for researchers to put together a sample population. So, sample size is used in epidemiological research because some diseases are so prevalent that it would be too costly and near impossible to survey every person afflicted with the disease. And so, therefore, sample sizes aid epidemiological research by allowing researchers to only survey a subset of the total population while still assessing accurate results. So, the biggest misuse with sample size is having a small sample size. And a small sample size leads to selection bias, underrepresentation, and unreliable results. So, when choosing a population to survey, selection bias implies an unbiased amount of individuals from relative subpopulations. And that is to mean that one specific subgroup from the target population is overrepresented in the sample size. This in turn leads to underrepresentation of other groups and ultimately confers unreliable results. And this is a big problem with having a small sample size. So now a real life example of this could be if we were to do a survey on Canadian doctors' work-life balance. So now there are more than 96,000 physicians in Canada, but only roughly 7,000 of them are located in rural communities. So if we were to take a randomized sample, we would more than likely underrepresent doctors in rural communities. This would in turn give us an unreliable result and give research not a full picture of the work-life balance among different Canadian doctors in urban and rural locations and across various specialties. So we can correct this misuse by collecting a larger sample size and prioritizing collecting diverse data points from all population groups.